All right, here we go. Last box, last portion of your 1-5 notes, and it says to express a plus bi, express in a plus bi form, and this is in your complex number form. So a is your real portion of the number, and bi is your imaginary. All right, and again, I is the only imaginary. I is imaginary, b is just the coefficient there. But here's what we're trying to get. We're trying to get the real number and then your imaginary number. So the goal then, just to be explicit about it, your goal is to get I, the radical, because remember I is the square root of -1. So square root of -1. We're trying to get the radical out of the denominator. Trying to get out of the denominator. This will be, you'll hear this called rationalizing the denominator. Rationalizing the denominator. All right, here we go. So those are our goals. We're trying to get rid of the radical in the denominator because this is, if you were to write it, in other words, this I here is an I. It's the square root of -1, and we can't have the square root, a square root in our radical. If that helps kind of make more clear what we're trying to do. So actually, let's change that back to the original I. Here we go. Now, if I have the square root of -1 in my denominator, well, then I'm going to multiply it by I, because what is I times I? We know that that is -1. That gets rid of my radical in the denominator. I can't just multiply the denominator by I, though. I need to keep this value of my fraction right here. I got to keep the value the same. So I have to multiply the top and the bottom by the same number. I essentially multiply it by 1. Because I divided by I, anything divided by itself is 1. So we've multiplied the denominators. Now let's multiply the numerator. We end up with 2i minus 5i squared. Okay? And now we've got rid of the radical in the denominator, but let's continue cleaning this up. So that's going to be equal to, well, I squared, that's -1. And -1 times -5, that's +5. And 5 plus 2i over -1. And that's a decent way to write it, but really, if we are being technical about writing it in a plus b form, we want to keep out our real number and our imaginary number. So probably the best answer we could have here is -5. That's 5 divided by -1 right here. And then minus 2i, because we'll have 2i divided by -1. So minus 2i. Here's our best answer. -5 minus 2i. All right, on to b. So in the bottom, if we didn't want I here and we just wanted to multiply by I, that might be kind of an initial reaction. If we did that, we'd end up with 3i plus 5 and still be stuck with a imaginary number here. If we multiplied by I again, it just moves on back to 5i. So we've got to do something a little bit different, but luckily we just learned just a moment ago, or a few videos ago, about how to cancel out our radical term, or in this case, our imaginary term, and that's to multiply by the complex conjugate. So we have 3 minus 5i. That means we're going to multiply by 3 plus 5i, and that'll get rid of our imaginary term in the denominator. And it's got to be multiplied by the same thing on the numerator and the denominator, because really we're multiplying by 1. Not changing the value, just changing the look of it. All right, in the numerator, we're going to end up with 6 plus 10i. That 2 gets distributed here. And then on the bottom, we have 9 plus 15i minus 15i. They cancel out. And then minus 25i squared. 25i squared. Maybe I should not be let's not assume there. Let's actually write in the so we had 3 times 3, that's 9. Then 3 times 5i, that's plus 15i. Negative 5i times 3 is minus 15i. Now you can see that they're canceling out. And then minus 25, let's move the screen over a little bit, 25i squared. Alright, so these two terms do cancel each other out, and we're left with 6 plus 10i over, remember I squared, that's negative 1. Negative 1 times negative 25 is plus 25, so 9 plus 25 is 34. Alright, and getting close here, but notice that we can simplify these out, and we're going to get, or I guess equals 6 over 34, and hey, that can reduce, plus 10i over 34, and reduce each of these, we get, let's see, 6 divided by 34, 2 goes in each of those, so 3/17 plus 5i 17. There's our real and imaginary numbers made explicit there. All right. Our C. We're on C now. We've got the same type of deal here, and we're going to be multiplying by the complex conjugate of the denominator. It's okay if we have an imaginary number up in the numerator. That's not a problem. So we're going to multiply both the top and the bottom by 4 minus 3i and 4 minus 3i, because again, that's 1. That gives us 20 minus 15i minus 8i, and then hopefully we can get close to just jumping to I squared. So negative 2 times negative 3, that would be 6, but I times I, that's negative 1, so we're going to end up with minus 6, because remember, negative 2 times negative 3, that's positive 6, I squared, but the I squared gives us negative 6. That's all being divided by 16 plus 12i minus 12i, those cancel out, and then 3i times negative 3i is negative 9i squared. But what is I squared? It's negative 1, so this is really over, or actually I'll write it over on the side here. Our denominator is going to turn into 16 plus 9 in the numerator. Simplifying that, we've got 20 minus 6, that's 14. And negative 15i minus 8i is minus 23i. Alright, continue simplifying. And we've got 14 25ths. Our numerator here is going to be, or sorry, denominator is going to be 25. So 14 25ths minus 23i 25ths. Alright, there's our answer for C. And lastly, now D. And D looks kind of complicated. We've got both a radical and a real radical and an imaginary number. But don't let it freak you out. We're still going to do the same thing to cancel out that term. So we're going to multiply it by 3 plus I root 5 over 3 plus I root 5. Same process here. So 2 times 3, that is going to give us 6. 2 times I to the 5th is plus 2I to the 5th. Over here we've got I to the 5th times 3, or sorry, not to the 5th, root 5. So plus 3I root 5. We're running out of a little bit of room here. And lastly, I root 5 times I root 5. And now the square root of 5 plus, times the square root of 5, that's going to be 5, because it's the square root of 25, gives us 5. And I times I, that's negative 1, so this is really minus 5. Again, we'll do that one over off to the side. I root 5 times I root 5. I times I is I squared, and square root of 5 times the square root of 5 is 5. And I squared is negative 1, so this is 1 times negative 5, so minus 5. Just in case that got a little bit too small there. Alright, that's our numerator, and we'll simplify that in a moment. And our denominator, though, we have 3 times 3, that's 9. And 3 times I root 5 is 3i times the square root of 5. And then negative I root 5 times 3 is minus 3i root 5. And so those are going to cancel out. Don't need to write those over there. They're going to cancel each other out. And then we have the negative I times the square root of 5 times positive I to the square root of 5. And so that's going to give us, I'm going to do the work down here and then put it up here. Negative I root 5 times I root 5. Well, I times I, that's I squared. The negative out front. So negative, then I times I is I squared. And 5, square root of 5 times square root of 5 is 5. Now, I squared is negative 1. So we have a negative, negative 1, that's positive 1, times 5. And then we will, so plus 5. Alright, there's all the work for that there, but all that turned into just 5. It's a really ugly way to write 5 right there. Alright, combine our like terms and start working through simplifying this one. So we've got 6 minus 5, so 1. And 2i root 5 plus 3i root 5 is plus I root 5 over 14. And this should be, oh, actually I should have added there. That's positive 2 plus 3, so this should be 5i root 5. Now as we get this into its real portion and its imaginary portion, we have 1/14 plus 5i root 5 also over 14. And there's your final answer. Alright, hope that helped.